Hey guys, Sean here. Hope you are doing well. In this video, we'll cover binary classification problem using Tensorflow. Okay, let's get started. Okay, let's start. Let's create a file first. Binary classification.py. Now let's import all the libraries. Tensorflow, STF, pandas, speedy, numpy, np, and matplotlib. Yeah, these are the four main libraries that we use in this problem. Now let's load the dataset. In this case, again, I have stored it in the GitHub repository. That we will get it right now. Dataset, you can find this dataset in my repository in this below link, like I'll mention it in the description. Odds, so in this case we will be data mining either like a patient is having a heart disease or not, like basically presence or absence. So that is why binary classification. Let's load it to data frame, and then let's print out the first few rows of the data frame. I will again, as you can find the details of each column in the link that I'll provide in the description, and we'll define target here. Target is nothing but target again, and let's also define our categorical columns. And basically not encoded before we split into training and validated dataset. That's why we do this before splitting. Categorical columns. XCP is nothing but chest pains, and FBS is nothing but fasting blood sugar, resting electrocardiographic result. Okay, and okay, this one is exercise. Sorry, exercise induced angina, and then we'll take CS is nothing but number of major vessels, and thal. So these are the categorical columns that I have defined in this problem. And now let's one hot encode it using pandas get miss function. We'll mention the categorical columns, and then again let's print out what is the next step. Okay, let's the columns, sorry, rows. Okay, so you can see here it's been not encoded. And now let's remove target from this, or maybe like we'll split it into training and validate dataset. Train and valid. Train data frame df sample 85% or your choice. Random state. 0. Validate data frame will remove all the train data set from the main dataset by passing in the training index. Drop train df dot index. So this will remove all the training data from the main dataset and store it in the valid data frame. Now let's remove the target columns. Target values, again as I said before in this video, it will give numpy arrays. Values, okay, values, and now let's do the scaling here. We'll again follow what we did in previous videos. scaling. Stats, we'll obtain stats, and we'll do again with the only training data sets, in order to avoid data leakage. We'll scale both training and validate dataset only using trained dataset. So train df minus stats mean divided by standard deviation. Again we'll repeat it for the validate data frame. Validate df minus stats of mean, and then divide it by stats of standard deviation. Yeah, that's it. Now let's convert. Okay, let's print so that we can see if it is scaled or not. Okay, yeah, if you can see here that it is scaled properly as we wanted. Now let's also store data for our future testing, like other than validation. We'll just print out how it is trying to predict the data. We'll just take the first value from the training data frame, prediction data. We'll name it prediction data. Just remember this step. We'll use it in the later part of this problem. I'll just take the zeroth row of training data frame and convert it into numpy array, and again we'll increase the dimension using p.newAxis, because that's how a Tensorflow model takes the input, and the result will again take the first thing. Let's print out both the things. So we'll get the idea of what is there in each variable. So this is the thing. So we have scaled first row of the training data frame, and then result is 0th class. Now maybe let's also take two classes for our satisfaction, like if it is predicting both the classes properly or not. So if you see the data set that we printed above, the second row has the 1 as the class. So let's take second row also. Now let's print out both the variables. Prediction data 1. Basically prediction data 0 means like that data should be of class 0. Prediction data 1 is of class 1, like with or without hard disease. So both will validate prediction for both the classes. That is the point. Converting to numpy, train data will new variable. We'll define new variable if in case we need to use train data frame the future references or something like that. So we'll convert it here, and then we'll again write the same function that we wrote in my previous video, converting numpy to Tensorflow datasets. Let's do prepare datasets. We'll pass in data, labels, comma, batch size, shuffle buffer, and let's convert again here. Datasets is equal to t of data dataset from tensor slices, and we'll pass a tuple with data and both data and labels. Then we'll shuffle it so that there will not be any bias in the ordering of the dataset. So let's now batch create a batch of size batch, and then prefetch 1. Again, as I explained in my previous video, prefetch will give the next batch already. It will make the next batch already ready for training loop. So training loop, or the processor don't have to wait for the next dataset to come. So it's basically an efficient way of doing training. It's a recommended way that Tensorflow has given. So let's create a tensor train dataset by passing batch size and buffer. Batch size will create take as 32, and buffer we will assign it to 50. The same way we'll create valid dataset, valid prepared dataset, when we'll pass in valid data and valid labels, and then batch size and buffer. Okay, now again the data creation of data preparing dataset is done here. Now we will move further towards creating model. So this is a binary classification problem. Just keep this in mind. There is a change compared to our previous linear regression model. So we'll create a 3-layered deep neural network. It's not that deep as we are dealing with very lesser data. Create a dense layer. We'll take 512 neurons in it, activation ReLU. Again one more layer, dense, 128 probably, or your wish, ReLU. And again one last layer, Tensorflow class layers dense, and we'll use only one, and activation here we'll use sigmoid activation. This activation basically converts any value between 1 and 0. So you can actually define a threshold to basically class either 0 or 1. That depends on you. Now let's, for the fit, we'll pass train dataset, epochs. We'll just, for sanity test, we'll take 10, divided dataset, and that's it. Validation data, dataset. Yeah. Now let's keep again, just pay attention to compile as well. The loss function, optimization function is what things will change. Losses. Here we use binary cross entropy. In earlier linear regression we had used MSE, mean squared error. Here we are using binary cross entropy as the loss function, and then optimizer use SGD, stochastic gradient descent. Metrics will again we'll use accuracy and MAE. Yeah, we'll take both here. Now let's do a sanity test. Let's run it. Oh, we are fine with the model and dataset. So in first go we are able to achieve this. So let's now plot the graph, and also if you can observe in our training, ME has decreased and accuracy has increased. So we are on the right track. Let's now create the plots for all the things rather than doing it twice as we did it in the previous video. Now let's do it using a for loop for all the plots that we need. Name the metric. History, will take history, and then we'll pass in the string peer plot. Validation metric, history. Now val plot, yeah, and now let's define epochs. Epochs is nothing but the same length of that of the metric. Like for each epoch what is the metric, for each epoch what is the validation metric. figure size 15,10. This is my favorite size so far. Plot epochs versus metric. Label it training plot. Oops, plot. PLT plot. Epochs validation metric. Label validation plot. F validation plot. Okay, I missed it here. Let's now also provide legend in the plots and title, training, and validation plot for plot. Okay, now let's show. Okay, I think we are done. Okay, plots. Now I think we are done plotting. Now let's do a sanity test again. Yes, we are fine. So if you can see here, accuracy has increased 85 for only 10 epochs. Now this is MAE, it has decreased, showing good sign again. For 10 it has reduced to 0.32. Loss also has decreased. Yes, all the graphs shows that we are on the right track. Now let's since the sanity test is done, let's train it for like 100 loops. Also let us predict. So like we had stored prediction data before 1 and 0. Let's use those data and try to predict. This is predicting zero class prediction data 0. Okay, now prediction 1 is equal to model.prediction prediction data 1. Okay, let's print it out. Print expected result result 0, prediction result prediction 0. Okay, now let's do copy paste, do it for one class 1. Okay, reformat it. Okay, now let's predict 100 epochs and see how the prediction goes. So you can see 93% has been reached. Okay, validation is fine. It is not dropped, so it's cool. Now let's check MAE. MAE has also fine. It is improving for each epoch. It's a good sign. Now let's check the loss. I think it has gone a little up for validation loss. Maybe 40 is enough. Oops, let us print. Okay, I print. Now let us go for 30. Okay, around 91%, validation around 82%. Loss, yeah, it has decreased. So here, yeah, as we saw in the previous thing. So here, as you can see, 70. It is, if we set the threshold for 0.5, then it is predicted correct. Now let's increase 100 box and train it. Let's see the prediction. Okay, 90 over 90. MA fine, MA is fine. Loss is kind of okay. Yeah, here if you can see, for 0 it has predicted 0.0, it's nothing but 0, and for 1 it has predicted 0.8, so close to 1. So it has done better. So we can also do some experimenting by changing batch size, and also by providing learning rate to SGD. And that is up to you. So this is a basic binary classification problem, and yeah, that's it guys. Hope you enjoyed it. And next I'll be doing a multi-class classification problem. Hope you guys enjoyed too. Okay, thanks guys. Okay, cheers.